Okay, here we go. We are ready to go over lesson 3.2 using parallel lines and transversals. In 3.1 we identified angles formed by transversals. Now we're going to look at angles formed by transversals where the lines are parallel. Yes, we're going to get into some theorems here, one of my favorite lessons. So first off, you can freeze the page here. You can go back and review these warm-up exercises. So freeze the page and then check your answers. Okay, you can see if you got them right. So you can also explore parallel lines. It's my intention to do this in class. We're going to draw a pair of parallel lines and cut by a non-perpendicular transversal on lined paper. Trace your drawing onto tracing paper. Move the tracing paper to position 1 of the traced figure over 5, and you'll see that 1 and 5 are congruent. You're going to compare this. So there is a postulate 15. What I want you to know is the corresponding angles postulate, which says what you just saw. If two parallel lines, so P and Q, are cut by a transversal, then the pairs of corresponding angles are congruent. So 2 and 6 are congruent. In this example here, 1 and 5 would have been congruent, 3 and 7 would have been congruent, 4 and 8 would be congruent. So, the measure of 3 of the numbered angles is 120. Identify the angles and explain your reasoning. So, you guys know that this and 5 will be congruent because of what we just learned, corresponding angles postulate. You might also remember, or you should remember from chapter 2, there's a vertical angles theorem. So 4 is congruent to 120. You know that from the vertical angles theorem. 8 is equal to 120, and you know that from the vertical angles theorem. Okay, there's also other theorems. There's an alternate interior angle and an alternate exterior angle theorem that says that when those angles are created by two parallel lines cut by a transversal, and you notice the parallel line markings here, then they're going to be congruent. Okay? So, I knew that 120, that angle 4 was equal to 120 because it was vertical angles theorem. I also knew that 5 was 120 because of the corresponding angle postulate. 5 and 4 are also, 4 is, we already said 120, 5 and 4 are alternate interior angles. So I know that 4 is equal to 120 because of the vertical angle congruence theorem I learned in chapter 2. But I also know that 4 is equal to 5 because of the alternate interior angles congruent theorem I'm learning in chapter 3. And this is where proofs get a little confusing, because if I proved that 4 was equal to 120 because 4 and angle 1 are vertical angles, or if I proved that 4 and 5 have an equal measure because of the alternate interior angle theorem, either option would be correct proof. There's also the consecutive interior angles theorem. 3 and 5 are on the same side. They're not going to be congruent, but they are going to add up to 180. They are going to be supplementary. So, we can start using algebra and using the properties of parallel lines to find some values. So, there's a few ways we can do this. I'm not looking right now at how they did it. 115 and 4, measure of angle 4, are going to be equal. So that's going to be 115. I think they do this. Measure of angle 4, which is 115, plus this equals 180 because of the consecutive interior angles theorem. Then we can just solve and we can find that x is equal to 50. So, guided practice. I'm going to, this is a chance to pause the video, See if you can find the answers, and then say which postulate or theorem you used. So pause it. Okay. Angle 4 is 105 degrees. Angle 1 is 105 degrees. 1 and 4 are vertical angles congruence theorem. Now, angle 1 is 105 degrees. Angle 5 is 105 degrees because of the corresponding angles postulate. And 8 is 105 degrees. Remember, we're asking you to compare it to 1. So 1 and 8 are alternate exterior angles. Yes, once you find 5, you would also know that 8 is 105 degrees because of the vertical angles theorem. Number 2, guided practice. The measure of angle 3 is 68. And the measure of angle 8 is 2x plus 4. What is the value of x? Show your steps. Well, I like to start filling these in. If 3 is 68, 3 and 7 must be 68 because they're corresponding angles. And the two angles, the 68 plus 2x plus 4 equals 180. 68 plus 4 is 72 plus 2x equals 180. Think you can finish it from there. I'm going to move this box away because I think sometimes it's easier to see their writing than mine. It's a little bit clearer. There are your steps. Now they're asking us to do a proof. They want us to prove the alternate interior angles theorem. They've told us the theorem is true, but they want us to prove it. So they ask you to draw a diagram, label a pair of alternate interior angles, angle 1 and angle 2. And this is the thought process. You are looking for an angle that is related to both 1 and 2. Okay? Notice that one angle is vertical with 2 and corresponding to 1. So I labeled this 3. We're told that P and Q are parallel. If they're parallel, then we know that 1 and 3 have to be congruent because of the corresponding angles postulate. We also know that 2 and 3 have to be congruent because of the vertical angles theorem we learned in chapter 2. So I'm going to use those two pieces, and let's see how they laid out this proof. Just like we said, they gave us P is parallel to Q. We know that angle 1 is congruent to angle 3 because of the corresponding angles postulate. We know that 3 is equal to 2 because of the vertical angles congruence theorem. So if 1 is equal to 3 and 3 is equal to 2, 1 is equal to 2 because of the transitive property of congruence. Notice we did not need to use any measures here or any equalities. We were able to just use transitive property of congruence. So now we want to solve a real-world problem. Sunlight enters a drop of rain. Different colors of light leave drops at different angles. This process is what makes a rainbow. For violet light, they told me that the measure of angle 2, so where the violet light is hitting, is 40. And these lines are parallel, so what's angle 1? Well, it must also be 40 because they are alternate interior angles. Okay? And that's all the solution. Now, in the proof for example 3, if you use the third statement before the second statement, could you still prove the theorem? So if you said 2 and 3 are vertical, and then 1 and 3 are corresponding, what do you think? Could you still use the same theorem? Think you got it? Yes. You could still use the same theorem, and that's why sometimes kids get confused as proofs. This could be step 2. This could be step 3. And you would still be able to prove congruence. Suppose example 4 shows yellow light leaving a drop of rain. Yellow light leaves the drop at an angle of 41 degrees. What is the measure of angle 1 in this case? So let's look at this. So let's say the angle here is 41. So we're going to draw a new transversal, okay? And we're going to label that 41. Now we have an angle there that's 41. Let's go back and look at what the question actually says though. Okay, so they want you to find the measure of angle 1 in this case. Okay, once again, because the alternate interior angles are congruent, it's 41. Here's your daily homework quiz. See if you were able to follow the concepts. So you can pause this here. I'm going to pull these away. Okay. And now looking at number 4. See if you can do this. They want you to find the value of x and y. Pause it, see if you can find the answer. 17.5 and 35. I'm going to go through this one in case you have a hard time. These are parallel lines cut by a transversal. So I know that this, a few different ways I could do this. Okay. There's a transversal here. So this is 2x plus 10 here. I should erase this one. This doesn't help you. So let me go back and make sure you can tell where all of these lines are. This. This is a parallel line. This is a parallel line. It's actually cut by 2 transversals. Transversal here. And there's a transversal here. So I'm going to first look at this. 2x plus 10 is that y though? That's y, so I don't want to use that. So I'm going to use I want to use the 2x plus 10 and the 6x. Since these are both interior, that and that, this angle plus this angle is going to equal 180. So 2x plus 10 plus 30 plus 6x is going to equal 180. So 2x plus 6x is 8x, 10 plus 30 is 40, equals 180. So 8x equals 140. I subtracted 40 from both sides. Got my calculator here so that I can do 140 divided by 8 is 17.5. So x is 17.5. Okay, I'm going to erase some of this so I can see what I have here. Now I also have these two, where 2x plus 10, hold on a second. Write this over here, x equals 17.5. I'm going to clear my annotations here. I just lost that. Oh, x is equal to 17.5. So now I have this angle and this angle are equal to each other. 2x plus 10 is equal to y plus 10. Know that x is equal to 17.5. 17.5 times 2 is 35. Should have been able to do that in my head. 45 equals y plus 10. Subtract 10 from both sides. 35 equals y. So while that one was a little bit more complicated, I still was able to figure it out by trying to figure out which ones to use first. And as you saw, even in my case, it was a little bit of trial and error, because at first I saw that 2x plus 10 was going to be equal to this, but I realized that this was going to have an x and this was going to have a y, so I couldn't do that one yet. I had to solve for x and think about which postulates and theorems I wanted to use. Notice they did not ask me which theorem I was using, but once again, to do 2x plus 10 plus 30 plus 6x equals 180, I'm using the consecutive interior angles theorem, where these are going to equal 180. And then once I solve for x, I could use the alternate interior angles for the alternate interior angles formed by the red parallel lines and the green transversal. I hope this has helped you with lesson 3-2.